Hello everybody. So in this video we're going to do a quick demo of the if statement and how it works. Then we're also going to look at some tools that are available for debugging in the Visual Studio Editor. And what is debugging? Well, I'll explain that when we get there, but basically it allows you to walk through your code in a step-by-step manner and to see what is going on at each statement of your program. And then at the end we're going to finish this video by doing a quick demo of the Boolean variables, or how to deal with binary variables and how they work in C. So let's start. This code that you see in front of you, this was taken from the book. I believe this is given in figure 2.13. And we've discussed this in the slides already. What this program basically asks you to do is to enter two integers, and then it will tell you the relation between those two integers. So it will pass the two values through different if statements and see if the two variables are they equal to each other, are they not equal to each other, or is one less than the other, or greater than the other, or greater than or equal to the other. So let's first run the code and see what happens. Okay, so first you are required to enter two integers. So let's enter 3 and 7, and so what the program tells you is, well, 3 is not equal to 7, which is true, right? And then 3 is less than 7, which obviously makes sense. And then of course 3 is less than or equal to 7. So of the, I think we have about 7 if statements in here. So out of those if statements, 3 statements are satisfied, and those statements are this one. So 3 is not equal to 7, then 3 is less than 7, and then of course 3 is less than or equal to 7. So all these 3 statements are satisfied. So what the program does is, when it comes to each of these if blocks, when this relationship is true, then it goes inside its body and executes the statements inside the body, and we only have one statement which basically is just printing the relationship between the two variables or the two integers in words. Now let's try another example. So let's say maybe I try 8 and 2. So in this case you have 8 is not equal to 2, which is true. 8 is greater than 2, which of course is also true. And then of course 8 is either greater than or equal to 2, which also makes sense. And then finally maybe one more. Maybe we can write something like 5 and 5. 5 is equal to 5. 5 is less than or equal to 5. 5 is greater than or equal to 5. So all these 3 statements are satisfied when integer 1 is 5 and integer 2 is also 5. Okay, so That's pretty much what or all that I want to say about the program. The next feature that I want to introduce is a very useful feature of Visual Studio. It also exists in most modern IDEs. It's called debugging, and debugging is very useful if you want to step through your program and want to see what is happening exactly at all places in the program. So with debugging you have the option to execute all statements one by one and then seeing exactly what is happening at each statement. You will find debugging options here. If you click on this menu, you actually see that F5 is to start debugging, and then the options that I actually want to discuss today is a step over. So what is the step over? It's generally you can either come here and click step over or press the F10 to do a step over. A step over basically allows you to execute the statement that you are at any given point in time. Toggle breakpoint is triggered by F9 and basically allows you to insert or remove. So toggle is basically turn on or turn off, so allows you to add or remove what is called a breakpoint. And breakpoint basically is a point in your program where you want the program to stop. So if I go to my program here and I go to line number 13 and I press F10, so if I go to line number 13 and I press F9, what you will actually see is this red button or red light kind of comes on, and it basically indicates that I have inserted a breakpoint here. If I press F9 again, you see that it kind of goes out. Another way of inserting is to actually take your mouse here or your cursor here and press the left click once and it will appear. If you press left click again, it disappears. So now if I have inserted a breakpoint here, when I actually go into debug mode, so if I press F5, what my program will do is it will come here and it will stop at line number 13. Now if you see at line number 13, what you actually see is everything that took place, all statements before line 13 have executed. So what you see is enter two integers, and I will tell you. So this is the first printf statement. If you press F10, which basically was the step over feature, so you will execute line number 13 as well. So let's go ahead and do that. So now once we do that, you actually see that it prints the next statement, and I will tell you the relationship they satisfy. Now if I press F10 one more time, my scanf statement will execute, which means that my program will wait for me to enter two numbers. So if I enter 3 and 6, now you see that it comes to the next statement, which is at line 20, and now it will see, okay, is num1 equal to num2, so is 3 equal to 6? No. So if that is not the case, then you see that my program has actually skipped this line, has gone and stopped at the next statement. And then what it does is, if I execute this line, yes, 3 is not equal to 6, so I go into the next into the body of the if statement, and then if I press F10 one more time, you actually see that it prints 3 is not equal to 6, and then you can kind of keep going in this fashion. So is 3 less than 6? Yes, and then it prints that, and then so it prints 3 is less than 6. And then if you want to, so let's say now you don't want to go line by line and you want to just continue the rest of the program without looking at all the other lines one by one, you can press F5 and your program will actually complete execution, and it will stop. So you actually see that it executed one more print statement and then it stopped. Now quickly, there is one more thing that I want to demonstrate. So if I run this program again, when you actually execute this, now notice once you actually executed lines 15 and 16, you see that you get these integers num1 and num2. So these variables, you can actually now see their values as well, and you can see the types as well. So you can see num1 is an integer, num2 is also an integer. It also shows you their values. Now right now these values are basically their initialization values, and these are the default values that are going to be stored in these variables unless you store something in them. So now if I execute the scanf statement and I enter two numbers, let's say 6 and 8, what you will actually see is that the values change. So num1 now stores a value of 6, num2 stores a value of 8. Another thing, you'll actually see this and num1 and num2. This basically, these two rows show you the memory address where these numbers are currently stored. So you know, num1 is stored at this location, num2 is stored at this location, and so this is also useful information. So this information, this type of information can actually be very useful when you are trying to debug your program. You're trying to see how things are going, what could be going wrong, what is not going wrong. So this is very useful from a practical practical perspective. Right, and so the final concept I want to illustrate is basically related to what is called the Boolean data type or the Boolean variable. So let me just quickly comment this code out, and I will quickly add code for that here. So what I want to introduce is basically the Boolean data type. Now these are very useful from a decision making perspective. And they're basically used to store binary variables. So binary variables which are true or false, but there are different ways that you can actually put data in them, and so I just want to give you a quick demo of that. So if I define a Boolean variable using the keyword bool and I call it a, now I can give this a different value. So I could say that a is equal to 0, which would mean that this is false. I could call a as 1, and it would then, the program would interpret that as the Boolean variable a being a true. I could also take this and write this as true, and again, even though this is kind of like a string, this is true is a keyword, so it will interpret this is as being true, so it will interpret it as is. Another thing that C allows me to do is to write this as false, and this would also work. Another thing that could work, another interesting thing is that I can even do something like this. So I can say a is 100, and now whether this will be interpreted as true or false, well, we discussed in the lectures that anything that is not 0, so any number that is not 0, so that would basically be stored or interpreted as being true. So now, in order to see what value is interpreted as what, let's just go ahead and print these values of a one by one, and that will show us how the program actually interprets these values. Now remember that a boolean at the back is generally stored as an integer. So if you're going to use the format or the delimiter for the boolean, that has to be, you can use the %d as the delimiter. So if I print a here, now over here the value of a was 0, then I change that to 1, here I change it to true, here I've changed it to false, and here I've changed it to some non-zero integer value. Now let's go ahead and run this and quickly see what happens. Okay, so a is 0 is interpreted as 0, so it's interpreted as false. 1 is interpreted as 1, so it's kind of is interpreted as being true. Now true is converted to 1, so again, computer doesn't store true, it actually stores that as a 1, and a 1 basically represents a true condition, or the value of a being true. False shows up as 0, and then you can see that 100 shows up as 1, so it's also interpreted as true. So that's interesting, some interesting stuff about the Boolean data type. We will study it in a bit more detail in later chapters, but we've just touched it, and so we've now discussed, I think, or at least touched most of the important basic data types of the C language.